Hello students, today we will learn Fermi level in intrinsic semiconductors, in which we will see the position of Fermi energy level in energy band diagram of intrinsic semiconductors, as well as we will derive the expression of Fermi energy level in intrinsic semiconductors. So this is the energy level diagram of intrinsic semiconductor when temperature is greater than 0 degree Kelvin. The Fermi level lie exactly at the center or bottom of the conduction band EC and top of the valence band EV. It means that EF is equal to EC plus EV by 2. In other words, the difference between the bottom of the conduction band and top of the valence band EV is called energy band gap, and the Fermi level is exactly half of the energy band gap. So before going into the expression, first of all, we'll see what is Fermi energy level. So Fermi energy level is the highest occupied energy level in intrinsic semiconductor. So the energy level up to which all energy states are filled at 0 degree Kelvin and above which all energy states are empty, called Fermi energy level. And the energy corresponds to that Fermi level is called Fermi energy, which is denoted by EF. F is in the suffix. Now we will derive the expression of Fermi energy level in intrinsic semiconductor. So we know that in intrinsic semiconductors, at the temperature greater than 0 degree Kelvin, the concentration of electrons, free electrons in the conduction bands is equal to the concentration of holes in the valence band. It means that N equal to P, where N is the concentration of electrons in conduction band of the intrinsic semiconductors and P is the concentration of holes in the valence band of intrinsic semiconductors. And we have already derived the expression for concentration of electron and concentration of holes for intrinsic semiconductors. So what is concentration of electron? That is Nc into exponential of EF minus EC by kT, and concentration of holes in the valence band of intrinsic semiconductor can be given by this expression Nv into exponential of minus EF minus EV by kT, where EF is Fermi energy, EV is the energy of top of the valence band, EC is the energy of bottom of the conduction band, and Nc is the effective density of states of conduction band, and Nv is the effective density of states of valence band. Now we will take natural logarithm on both sides. Okay, by taking natural logarithm on both sides, that is natural log means log to the base e, that is denoted by ln. So we are taking ln on both sides. So after taking ln on both sides, we'll get these expressions. Ln is ln nc into exponential of ef minus ec by kt is equal to ln nv exponential of minus ef minus ev by kt. Now we will apply the log rule. We know that the logarithm of the product of two parameters is nothing but log a plus log b. So here is natural logarithm ln of nc into this exponential term. So after applying log rule, this will be ln nc plus this exponential, here also ln nb plus this ln exponential. So by log rule we'll get ln nc plus ln exponential of ef minus ec by kt. We already know that log a into b is log a plus b, so log a plus log b. Here is also natural logarithm ln nv plus ln exponential of minus ef minus ev by kt. Now we will see that this second term of left hand side and this is second term of right hand side. Here is ln and exponential, here is also ln in an exponential, and we know that ln means natural log. Natural log and exponential are inverse of each other, so they will cancel out. Here is also natural log and exponential inverse of each other, so they will cancel out, and only this power will remain exponential. This ef minus ec by kt and here is minus ef minus ev by kt will remain in the second term of RHS and second term of LHS. So in next step we will get ln nc plus ef minus ec by kt, and here ln nv minus ef minus ev by kt. Now we will shift this ln nc here on right hand side. Okay, so here is plus ln nc, so this will go to right hand side, so it will become minus ln nc. So we'll get ef minus ec by kt is equal to ln nv minus ln nc minus this term ef minus ev by kt. Now ln nv and minus ln nc, that is log nv minus log nc, natural log nv minus natural log nc is nothing but natural log NV by NC by logarithm rule. Log A minus log B is log A divided by B by log rule. So we will get in this step ln NV by NC by logarithmic rule. Okay, now we will solve this step. Okay, so I am quoting same step in this slide. So this is the same step. Now we will multiply kt on both sides, because here is kt in denominator, so we will multiplying kt on both sides. So after multiplying kt on both sides, we will get kt multiplied by this term is equal to kt multiplied by this term minus kt multiplied by this term. Now kt divided by kt is 1 here, kt divided by kt is 1 here. Now in next step we'll get ef minus ec is equal to kt ln nv by nc minus ef minus ev. Now we'll solve this bracket, minus ef minus minus plus here. So in this step we'll get minus ef plus ev. Okay, so same step we'll quote in next slide. So before that, this ef will take to that side and ec to that side, so it will become plus ef here and it will become minus plus ec here. So after shifting that, we will get ef plus ef is equal to kt ln nv by nc plus ev minus ec. Here ef plus ef is twice ef. Now we know the formula for nv, that is effective density of states of valence band, and this is effective density of states of conduction band in intrinsic semiconductor. So nv nc will know. So this is the formula of nv. Okay, and this is the formula of nc. All terms of are same except this mh and me. So if we divide nv by nc, all terms will cancel out, only the term mh and me will remain. So nv divided by nc will get mh by me. Okay, so after substituting those values of nv and nc, we will get ln of mh by me, ln of mh by me, and here ef plus ef is twice ef. Now if consider this is the effective mass of hole and this is effective mass of electron. Okay, if we assume that, or we consider that the effective mass of hole and effective mass of electrons is almost approximate equal, mh is equal to me, so we'll get here ln of 1. So therefore our equation becomes twice ef is equal to kt ln of 1 plus ev plus ec, and ln of 1, that is natural log of 1, is 0. So natural log of 1 is 0, so this term will be 0. So we'll left with this 2ef is equal to ev plus ec, and this 2 will bring to that side into division. So ef is equal to ev plus ec by 2. It means that Fermi energy is the Fermi energy level lies exactly at the half, okay, exactly in the middle of ev and ec, that is ev plus ec by 2. This ev is the top of the valence band and ec is the bottom of the conduction band, and divide by 2, it means the Fermi energy lies at the center of top of the valence band and bottom of the conduction band. So therefore it is concluded that Fermi level in intrinsic semiconductors lies exactly at the center of eg, because ev plus ec is eg. Okay, so ef is equal to eg by 2, ev plus ec is eg. So Fermi energy level is located in the middle of eg. It means that it is located exactly at the center of top of the valence band and bottom of the conduction band. So today we have seen what is Fermi energy level, where is the position of Fermi energy level in intrinsic semiconductors, as well as we have derived the expression of Fermi energy level, and we have proved that the Fermi energy level lies exactly at the middle of eg, means exactly at the center of bottom of the conduction band and top of the valence band. So thank you very much.